Hello. So, this is a different video than anything in my channel. In my channel is basically just a deposit of my speedruns. So, yeah, some of you might know I'm an undergraduate student, physics student in Brazil. And I intend to go into astrophysics, cosmology and all that, but that's not important for this video. And I'm a big hater. I would say it's a good word to describe what I am. I'm a hater of pseudoscience. And what's pseudoscience? Pseudoscience is when people try and use concepts from real science to mislead people into giving them money or taking advantage of them in some way, shape, or form. And there are many ways that people do this by astrology, for example, acupuncture, everything quantum that people just put the word quantum in it, and it's got nothing to do with physics. And the reason I'm making this video is I was browsing YouTube the other day, and there was a video by YouTuber Matthew Santoro. He's a Canadian YouTuber, I believe, and he has 6.4 million subscribers as of the recording of this video. Yeah, 6.4 million subscribers. So, a lot of people. That's a lot of audience he has. And his content is basically easy to digest content, like top 10 videos, or like 10 facts that will blow your mind, 50 facts that will blow your mind. I think it's his longest ongoing series on this channel. And he often goes into things like creepypastas, urban legends, conspiracy theories, and whatnot. So I saw that he uploaded a video called 10 Quantum Physics Facts to Blow Your Mind. So since I've seen so much stuff about quantum woo and whatever, I already knew that this video was probably something like that, but I decided to give it a try, and boy was I right. This video is pretty bad. Starting from the fact that he calls it quantum physics, that's not the name. That's only one physics. The branch that studies the quantum realm of reality is called quantum mechanics, just like the physics that we experience daily on our daily lives is called classical mechanics. So calling it quantum physics already makes it sound like it's something more mystical and magical than it really is. Don't get me wrong, quantum mechanics is something that's really counterintuitive, even for physicists like myself. And I can only imagine what it is for people who don't know anything about physics. And considering that his content is easy to digest, as I've previously said, I can only imagine that his audience is of a younger age. So for people to be misinformed about quantum mechanics, something counterintuitive and that can be used by many people to mislead you into giving you their money or whatever, I think that's very harmful. And I've already watched the video multiple times to get mad, probably, and I'll be giving my thoughts on the video as I watch it and record it, because this is a serious thing, and I think with the advent of the internet, it's become even more common that people have misconceptions about quantum mechanics and physics in general, try to use it as an argument to justify some bogus idea that they have, and I don't want that spreading. And this video was posted, what, like 2 days ago, 4 days ago? 27th of December, today is 29th, so 2 days ago. And I didn't see anyone talking about this video at all, like from the scientific community. I also didn't see it being shared a lot, but that might be just because I don't follow the right people, or the wrong people. Depends on who you ask. So that's what I'm gonna do. I'm gonna be watching the video and giving my thoughts on it. There are 10 quantum physics facts. That's also a big red flag, saying something it's a fact. And yeah, I'll begin the video, and I'll be pausing it and giving my thoughts on it.
Hey guys, before we begin, I want to let you know that this episode is sponsored by CuriosityStream.
So right off the bat, 5 seconds of video. He says that the video is supported by CuriosityStream, sponsored by CuriosityStream. And that caught me off guard. And that's because CuriosityStream, from all I've heard from other videos that were supported by CuriosityStream, I don't use it, but it seems like a very good platform, like a very informative platform with very good content. And they've sponsored channels such as PBS Spacetime, which is a fantastic real science channel. So seeing that they sponsored a content creator like Matt, not trying to shit on his content at all, but that doesn't match. At least to me, it doesn't match at all. Oh yeah, I'll probably cut or not watch the parts where he tries to be funny, because I personally don't think it's funny and it's not on the scope of this video. So I'll just cut them.
Happy videos again. Yes, we're back. If we can just focus. Okay, there we go. The universe is a strange place filled with intrigue and wonder. Throughout human history, we've developed theories about how our universe works.
So I want to stop at this here, at this sentence, because you see how he used the word theory, and the word theory is something very special for science because it differs from what the normal person understands as theory. The normal person thinks of the word theory more as hypothesis, which is something completely different, speculative, while theory is something that agrees with experiment and is a model of nature as we see it. And throughout the video, you'll see that the use of the word theory is very loose. It doesn't have a lot of care put into it, which I don't fully blame him for this. It's mostly scientific jargon, but saying that something is a theory puts it on the same level as something like theory of relativity, which is something that's been endlessly proven throughout multiple experiments. So when he puts it in the same level as that it can be harmful, because some of the things he says in the video, which he calls theories, are literally we're not able to experiment on them at all. So I guess that's oh yeah, and no, I'll leave the comment I was gonna make for later.
Based on the available evidence at the time. This led to religion, philosophy, and eventually science. But as science has explored the universe at a subatomic quantum level, the real truth underpinning all of reality has revealed itself to be stranger than any fiction. Here are 10 quantum physics facts to blow your mind. Number 10 is entanglement. Entanglement is easily one of the most bizarre parts of quantum physics. When two particles come into contact with each other, they create an entangled relationship. Now imagine you keep one particle, let's call it Tom. Then you send the other particle, we'll call it Jerry, to a scientist living thousands of miles away. You would imagine that the particles would now have no relationship because they are so far apart, but you'd be wrong. If you change the direction that Tom is spinning in, Jerry, thousands of miles away, will start spinning in the exact opposite direction instantaneously. It's not fully understood how this is possible, but we now know for a fact that this spooky behavior is real, because in July of 2019, scientists finally photographed entangled particles for the first time.
So here it talks about entanglement. Entanglement's something weird in quantum mechanics, but the way he talked about it was not wrong. But one of the things he said that caught my attention was that he says we don't fully understand it, which is not true. And I can't possibly begin to ask someone to explain entanglement that totally right in this short amount of time. but that's just not right. We do understand how entanglement works.
Our natural experience of the world is that things have a definitive singular state. A cheeseburger is a cheeseburger, and that's fantastic because they're so tasty. You'd be shocked if you were about to eat a burger and it suddenly turned into broccoli, which, ugh. Worse still, what if the cheeseburger was actually both a cheeseburger and broccoli at the same time? Thankfully, our experience of the world does not work like this. However, at a quantum level, subatomic particles like electrons appear to have what is known as wave-particle duality. Many physicists believe that particles are both physical points in space and, at the very same time, have wave-like properties. But how can an electron be both a particle and a wave at the same time? What's even more mind-bending is that some physicists believe even large objects, such as human beings, are waves as well. Well, yeah.
Oh, okay. That's where it starts hurting my heart as a physicist, because first thing is he talks sometimes like, oh, physicists believe, physicists disagree on something like that, and when he talks about like even humans can be waves, can display this characteristic, he's not entirely wrong. But this gives the idea that the kinds of weirdness that we see with subatomic particles could actually happen with me, with my cat, with my car, and that's not how it works, because basically the unit that dictates things in quantum mechanics, the Planck's constant. Planck's constant is something times 10 to the minus 34, and that's a really small number. But for an electron, it's not small, because the mass of the electron is 10 to the minus 31. So there's only 3 orders of magnitude separating these two quantities. But me, you can round up the mass of a person to 100 kilograms, for example. And that's 36 orders of magnitude. That's a lot. We're so much bigger than the Planck's constant. That's 1 followed by 36 zeros. That's a lot. I can't even begin to imagine this number. So when he talks like that, it makes it seem like I'm gonna go through my door and diffract. I've never seen a human diffracting. If you have, then that's concerning and you should see a doctor. But he gives this wrong idea that our world is ruled by the same rules as quantum mechanics, which is just not true. So, and he says that physicists believe that things can be a particle or a wave, and no, that's not true. Quantum field theory is the best theory humanity has ever come up with. It gave us the Standard Model, it gave us the Higgs boson in 2012, and quantum field theory says that a particle is a localized ripple in a certain quantum field. And quantum fields are fields that permeate the entire universe, and some of them interact with each other. And there are many. There's a field for each of the fundamental particles, all of the fermions and the gauge bosons. So for example, a ripple in the electromagnetic field, a localized ripple is called a photon, which is the gauge boson that mediates electromagnetic interactions. And a wave, an unlocalized ripple in the electromagnetic field is light as we see. That's very fundamental to modern physics right now, and there's just no debate that things have this behavior. So when he puts it like this, it seems like we have certain doubts of reality as we know, which is nowadays is just not true.
Number 8 is consciousness creates the universe. Now this one is controversial and it has been debated for 100 years, but nonetheless, it's a fascinating theory which still has the support of famous physicists such as Henry Stapp. This theory argues that consciousness is essential to the universe. Not only that, but that consciousness in some way creates the universe around us. Thinking back to the idea of things being both particles and waves at the same time, many believe that the reason we experience the world as solid objects is because the wave has to collapse into a solid point when it's measured. Henry Stapp believes that our minds are what causes this collapse when we look at things. The bizarre consequence of this is that when we are not looking at something, it doesn't really exist in any solid state. This is true, it is our minds which bring reality into being.
Oh god, this kind of thing is so hard to hear as a physicist because it's so fundamentally wrong in so many ways. And it's very easy, I think, for someone to understand what happens in this way. However, it's wrong. It's wrong. Consciousness does not create reality. Please don't say that. Oh my god. What happens is, I think many people get this idea from the double slit experiment. The double slit experiment is probably the most famous physics experiment, unfortunately probably because of these people misleading other people. And you have a cannon of electrons and you shoot them at two slits, and they have a chance of going through one of the slits and the other slit. And then they're detected with a detector, and wherever they land, you're gonna see a pattern. So what happened in the double slit experiment was, when they couldn't measure where the electron went through, from which slit did the electron go through? That was one of the questions. If they didn't have a way to measure, if they didn't have a detector there, we would see an interference pattern on the detector. And that should only be possible if the electron went through the two slits at the same time, which is not possible if you think of the electron as a particle. But if you think of it as a wave, that's totally possible, and that's what we see with water waves at a pond. If you throw if you let two pebbles fall in the water, in a calm water, you'll see that the waves they create will interfere. So when you try and measure which slit the electron went through with a detector, with a photon of light, you don't see this pattern anymore. The pattern disappears, and it acts as if the electron really went only through one of the slits. So you don't see interference pattern anymore. So, interesting. Now that we're looking at the electron, he doesn't behave in the way that he behaved when we weren't looking. So okay, I guess these people, they hypothesized, not theorized, okay? Two very different words. They hypothesized that, oh, if we're not looking, then the electron behaves this way, and if we are looking, then the electron behaves this way. But the thing is, observing, measuring something in science does not require a human being at all. A photon of light, if something shines a light into an electron, that's gonna interfere with how the electron moves or behaves. It's gonna exchange energy with the electron because the scale is so minimal, so small. A photon of light can change the electron's position or velocity or whatever. That's what the uncertainty principle says. So no, humans are not necessary for this kind of thing to happen. And then when he says that our consciousness creates reality, just what? There were things happening in your universe billions of years before human beings were even a thing. So I really don't know where these people get this from. So then you have the people saying, oh, now if you think positively, because of quantum mechanics, something positive will happen because you create reality. And no, that doesn't happen. And God, I think this is the worst crime of this video, probably. This is the worst part of it. And unfortunately is the most common misconception about quantum mechanics. So this was one of the biggest triggers for me to want to record this video and get a word out that this is wrong. This is wrong.
Number 7 is time doesn't exist. In his book, The Order of Time, theoretical physicist Carlo Rovelli makes the shocking claim that time itself does not exist. He believes that at a quantum level, the universe can be understood without even thinking about time. Rovelli points out that while we see the world changing in front of our eyes because time flows forward, quantum mechanics shows that this is nothing more than an illusion. Our brains have evolved to understand the universe and experience it in a certain way. At a quantum level, things happen, but not in any linear way. Cause and effect break down according to Rovelli because they don't actually exist in the way we have normally thought. He argues that the universe is chaotic and that we only order this information in order to make sense of the universe, when essentially the universe is a collection of random happening events.
So what he talks about in here is something that I'm not personally knowledgeable of. So when I did little research, I saw that Carlo Rovelli does have this conception about time. I don't know how to call it. But Carlo Rovelli is a renowned physicist. He is out there doing real research. And from what I've seen, he talks about time in more of a philosophical way, how we perceive time and what it means for us to perceive time. And I didn't see much of quantum mechanics in that, like hard quantum mechanics in these. So I'm not sure. I don't really have a lot of knowledge to talk about it, but it's just weird to see him put this in a facts video about quantum mechanics.
Number 6 are hidden variables. In our day-to-day lives, if we cannot understand something, we tend to think that we are missing something. If you try to fix a car engine, for example, and can't figure out why it isn't working, it's probably because you don't currently possess the knowledge required to fix it. In quantum physics, a similar concept is known as the hidden variable theory. This means that quantum physics appears so bizarre to us and so different from our daily experiences that we must be missing variables which would explain it and make it all understandable. However, some physicists believe that hidden variables by their very nature are undetectable. This means that we will never be able to understand reality no matter how hard we try.
So here he presents hidden variables as if it's something that's set on stone, if it's something that us as physicists have accepted that we're not gonna know about everything in the universe, when it's not really that in the context of physics, of science. Hidden variables was an attempt by Albert Einstein to show that quantum, or at least he hypothesized that quantum mechanics wasn't complete. We needed to know something else to be able to predict what the next result of our measurements were going to be. Because he didn't like the probabilistic nature of quantum mechanics that everyone else, like Niels Bohr and all of those guys, were okay with. He thought that the universe was deterministic. It's the famous God doesn't play dice. This is basically where this came from. This debate was the Einstein-Bohr debate in Copenhagen. It might not have been in Copenhagen. I don't actually know. But John Bell, an Irish physicist, he proved with the Bell theorem that if hidden variable theory agrees with quantum mechanics, it can be local. So we have to get rid of our concept of locality to insert hidden variables in in our reality. So this is a very weird thing to be in this video. I really don't know where this came from.
Number 5 is the many worlds hypothesis.
Alright, here I also know that there's gonna be some shit coming, and look how he says hypothesis. It's a weird dynamic exchanging theory with hypothesis in this video. I really don't like it.
Quantum physics is very strange, what with ideas like consciousness collapsing waves into single points and making reality.
No, that doesn't happen, Matt. That does not happen. Okay.
Turns out a lot of physicists agree, and that's why many believe they've solved this weirdness with their own theory, the many worlds interpretation. But as with all things quantum, even the solution to quantum weirdness has mind-blowing consequences. Theories suggest that every single possibility plays out at a quantum level. Your subjective experience is of a world where the wave function collapsed into one state, but there are potentially an infinite number of other yous experiencing different states. That means that there's a version of you who is a famous actor, and another version of you who is in jail for stealing something, you bad boy. Each moment you split into more and more versions of yourself. Now that's an identity crisis.
Okay, so this is just a flat-out misinterpretation of the Manyworlds interpretation of quantum mechanics. And so if you don't know, quantum mechanics has been, the interpretation of what quantum mechanics means has been debated ever since its discovery, I suppose. There's the Copenhagen interpretation, the Manyworlds hypothesis, and I guess de Broglie-Bohm pilot wave theory. These are the most popular interpretation of quantum mechanics. And Manyworlds, I think, is the most misinterpreted because it's pretty fantastic, I suppose. It's the weirdest out of all of them. And what happens is there are particles, electrons, for example. They can be in a superposition of two states, for example, two states to be simple. And when you measure, that state, the state function, which we call the wave function, it collapses to one of the two. And what the Manyworlds hypothesis says is that when we made that measurement, the moment we made that measurement, there was another universe that came out of nowhere, and where the other possibility happened, and then this other universe evolved by itself, independent of the other one. So, okay, that's what it says, but what Matt presents, he even says at each moment we're splitting into multiple parts and whatever. That's not how it works. Not every decision you make is ruled by quantum mechanics. If I go through my door, I have three possibilities. I can go to my parents' room, to the bathroom, and to the living room. When I make that decision, there's no other universe that it didn't split into three universes. One where I went to the bathroom, one where I went to my parents' bedroom, and one where I went to the living room. That's not how it works. Our lives, our daily lives, are not ruled by quantum mechanics. If that was the case, things that I mentioned previously, things like going through a door and diffracting would happen, and that just doesn't happen. And that's what many people understand as the Manyworlds interpretation, and I think that's what it's pretty famous with the cuckoos in the head.
Number 4 is quantum immortality. Staying with the many worlds interpretation of quantum physics for a moment, another strange consequence is the possibility of living forever. In fact, Hugh Everett, who created the many worlds interpretation, believed that the existence of many worlds guaranteed him immortality. Everett theorized that if every possibility plays out, that there would be worlds where the conscious observer dies and ones where they live. In fact, Everett believed that the conscious observer could never truly die and would always exist in one of those worlds. Others around that person might experience them dying in their world, but the person's consciousness would simply split off into another existence where they managed to escape death.
Yeah, that's one of the other things that people who want to present quantum mechanics as wow, this is so weird and quirky. They talk about just quantum immortality, which is nothing but a thought experiment like Schrodinger's cat. Yeah, so once again, he presents something as a theory, something that's completely not testable by the means that we have today. And he says that Hugh Everett was the guy that came up with the Manyworlds interpretation of quantum mechanics. It was a very well put together theory. He got all the flaws of the Copenhagen interpretation and he fixed it with his interpretation. However, the quantum suicide thought experiment was first published in, let me check here, 1987 by a guy called Hans Moravec, and by that time Hugh Everett was already dead. So no, Hugh Everett did not say any of that. And once again, he talks about consciousness, something that's not in the realm of quantum mechanics or physics in general. So once again, our boy Matt letting me down with the quantum mechanics, god damn it.
Number 3 is future Big Bangs. Cosmology tells us that the ultimate fate of the universe may be a very dark one indeed, but quantum physics may provide a way out of this depressing end. You see, a popular theory in cosmology is that all the matter in the universe will eventually unwind until there is no stars, planets, or fast food outlets. I kid, fast food will always exist. But seriously, that's what's called the Big Freeze, where the universe will go dark and essentially be so cold that nothing can really happen there anymore. However, some quantum physicists believe that in this event, over trillions and trillions of years, a phenomenon called quantum tunneling would eventually spontaneously create a new Big Bang. From the ultimate death of the universe would come a brand new universe, populated by stars, planets, people, and yes, again, fast food outlets.
So here it talked about, I even forgot the title he gave to it, New Big Bang, something like that. It talks about the heat death of the universe, which is one of the possibilities of how our current universe is going to end. And this is an actual hypothesis, this is an idea of what would happen afterwards, is because of the quantum fluctuations of vacuum, and according to the uncertainty principle, something could spawn out of that fluctuation. But it would be in a extremely disgustingly big time frame after the heat death of the universe, and it's completely untestable again, and from what I've seen from my research, it doesn't have many supporters. Sean Carroll, I believe, was a supporter of this idea, but he no longer supports it. But it was a fairly okay presentation of it. It wasn't a big mistake in this video, I suppose.
Number 2 is quantum biology. Biologists have always tried to understand life at a macroscopic level, but a new field known as quantum biology is adding its own mind-blowing insights to the animal kingdom. Quantum biologists believe that natural selection has led some organisms, if not all, to use quantum effects in some way. For example, the way plants turn photons of light into energy seems to require that plant biology uses quantum events to make this possible. Others theorize that the way that birds navigate using electromagnetic fields may may also require biology to process quantum information. But most striking of all are theories of the mind, which speculate that quantum events are not just used by the human brain, but may actually be consciousness itself, operating at a deep level within matter.
And now comes biology, which as a physicist I have no idea about. I don't know any biology. My biology knowledge ends at cats are felines and dogs are canines. But then he talks about consciousness and then he ruined everything again, Matt. God damn it.
And number one is something from nothing. When we think of the distance between objects in space, we usually have the impression of a dark void. Space is a vacuum. There's no air and therefore there's nothing in space. However, quantum physicists are showing that this idea is incorrect. Space contains things called virtual particles, which usually appear in pairs and then instantaneously cancel each other out. These particles appear to spontaneously arise, which is akin to something coming from nothing. It almost seems like a miracle, but where it gets really bizarre is that physicists like Lawrence Krauss believe that empty space can even generate the fabric of space and time from this void. This may be how our universe began in the first place. In fact, everything that's around you came from nothing.
You can see my cat now. Something that I was surprised about is that the first one is actually the least bad in this video. Once again, he mentioned physicist Lawrence Krauss, which is a renowned physicist. He is doing research, serious research out there. I believe in some capacity that I don't know about, this is a pretty completely feasible theory. And yeah, virtual particles do exist. Vacuum isn't really vacuum, there are fluctuations. And yeah, the first one was the best one, I suppose. I guess that's fitting. So yeah, that was the video. And you might be thinking, oh my god, this is such a long video, why are you recording this? There's no reason, no one's gonna see it. And I don't know, I feel like when things like this happen, it's very, very important for scientists to say something, say anything. Like, I don't know, quote the video and say, hey, that's wrong. I even left a comment in this video, which I don't think is gonna see ever. But there are so many people taking advantage of people who have no idea about these things to get money. And they prey on people who have either lost everything or they have used every single way of overcoming something, be it a disease, a relative that passed away and they're not being able to cope with it, whatever. And it hurts. It hurts the people who are taken advantage of. It hurts the scientific community because people come up to serious researchers with things like that and call them liars and oh, I saw it on the internet. And people like Deepak Chopra, biggest scam artist of all, they take advantage of this kind of hard concept. He tells people, oh, I understand this, no one else understands this, and they get money out of it. They're probably richer than any famous physicist ever. That might be a bold statement, but it really pisses me off when a content creator, this is not a personal attack on Matthew Santoro, but when you make a video like this calling things facts, you need to put at least a little bit of research, because these things are not easy to understand. He made a 12 minute video talking about some of the hardest concepts to understand in our reality that people have been studying for so long and don't understand still, fully at least. And I've mentioned in the beginning of the video that I assume that his audience is younger. It's like teenagers. And for them to be lied to, this is the word, be lied to, by a video like this, because he calls it the facts, the things he presents in the video. It hurts. It hurts for people who are trying to get interested in physics by what it is and not by lies. You can see many comments. This is my comment that has no upvotes, of course. So there are a lot of people really liking this video. Oh, happy video. Oh, Goofy Science Matt is back. Goofy Science Matt might be a character in his channel. And so many people who I even saw a comment saying, "Oh my god, this is so much more fun than school, learning through YouTube." And man, you're not learning, because most of the things here are wrong. And I don't know, I really feel like I have a duty to say something almost, because these things they happen so much, they happen so often, that you see movements like the Flat Earth movement getting bigger and bigger and bigger, and getting more audience and more people spreading that bullshit on the internet, which is just, it's not a debate. That's what people need to understand. Oh, or some late night shows or whatever, they get a flat earther and an astronomer to debate. There's no debate. It's not a debate. Science is not a matter of opinion. It's a matter of seeing the data. The data is here. Analyze it. Put it through tests. And nature will give you the results. And that's what we see. These are our theories. You only use Google Maps because of general relativity. You can only watch TV because of quantum mechanics. None of the things that you do in your daily life are due to things like astrology, like flat earth people, or I don't know. These are the biggest ones, I suppose. So anyways, that was video, kind of a rant at the end, but these things really hurt. They really hurt the scientific growth of younger people. They hurt the scientific community and science communication in general. And yeah, I hope if you watched this video at all, if you found this video on my channel, or randomly, and if you watched it, I hope you liked it. I hope you learned something. If I was wrong, anything that I said, I would be more than happy to be wrong, to be corrected. Yeah, that's it. Thank you.